Welcome to MODEX 2024. Let's give a round of applause, right? Woo! Let's get it. All right, let's go, Jason.
All right, we'll get going here. So thanks everybody for coming today. Still early in the MODEX, so everybody's feet aren't quite as sore yet, but that'll change here in the next few hours, I'm sure. Today we're going to talk about maximizing productivity via slotting, basically using the data to define what the system needs to look like or what the warehouse needs to look like. So today we have with us Carly Fells.
Hi, I'm Carly. I'm from Kansas City. I've been with Conveyor Solutions for 5 years now. Have a mechanical engineering degree, but in Kansas City in sales.
Very good. I'm Jason Effing. I'm Chief Revenue Officer for Systems in Motion. So I've been with the company about 10 years and based out of the Indianapolis, Indiana area.
My name is Michael Woolwin, born and raised in Chicago, and currently reside in Naples, Florida. That's what happens when you become an empty nester. Industrial engineer by trade. I went to Tuscaloosa, Alabama in 1993, and I tape measured 55,000 automotive parts. And I said, why am I tape measuring automotive parts? They're like, well, if you know the cube of the item, and you know how much of that item you sell, then you know how to properly size the forward pick location to minimize replenishment. And then if you know the cube and what you typically have on hand, then you know how to do reserve storage. So my very first project was for a company called Harco Carport, which got bought by Advanced Auto Parts. So my first DC back in 1993 is one of the 47 sites of Advanced Auto Parts today. So the foundation of my slotting came from cubing items and building facilities. So thanks for coming.
Perfect, thank you. So today we're going to talk about a case study that we did for a pharmaceutical company, Zoetis, and we're going to talk a little bit about Zoetis and what they do. Then we're also going to talk about systems in motion and what we do as a company, as a systems integrator. Then we're going to talk a little bit about the system we provided for the project. And then Michael's going to talk more about the Alpine portion, the study, the data analytics, and then also that detailed slotting analysis. So Zoetis is a global animal pharmaceutical company. So they do a lot for pets as well as agricultural animals and vaccines and pet products. So they're always on the cutting edge of new technologies in that space. So they had a distribution center in the Kansas City area that was outdated, and Carly will talk more details about that, but this is how we help them in their new facility. So Systems in Motion, we're based out of the Chicagoland area, and we're a holding company that's made up of different divisions. Conveyor Solutions, which is our systems integrator arm. We also have an electrical systems group, which is our electricians and our installation. MHIG from our mechanical installers. KVK is a UL certified controls house in Chicago. And then we have our aftermarket services to help once the project is up and completed. Along with that, we also have our software group that does a lot of the WCS integrations. So that kind of gives you a background of what we do and how we help customers. So I'm going to hand it off to Carly, and she's going to talk a little bit more about the specific project that we did.
Yeah, so like Jason mentioned, Zoetis has an existing facility in Lee Summit, Missouri, and they were wanting a new distribution center that was close to that. But they wanted to automate it to increase their efficiencies with storage, picking, slotting, and allow the capacity for future business growth. And then they needed an ambient and a cooler pick mod. That was like one of their priorities and what they needed with this new DC. So to put it into perspective, some numbers. Their old DC was about a third the size of the new one, but the output was over 16 times what the old one was doing. So went from 1,500 orders a day to 25,000, 69,000 square feet to 217,000. It used to take them 45 minutes to pick an order, have it go to the packing, have it go to shipping, and be shipped out. And now with this new system, it takes 5 minutes. And then again, their old system on the left side, you can kind of see it, but they're pushing the boxes on gravity conveyor. And with this new facility, we did a zone routing pick mod where the order is brought to that operator zone that they know they have SKUs in. So operators aren't walking up and down all the aisles trying to go find the SKUs. The order is brought right to them, and the conveyor is going 120 feet per minute. So just an overall layout, on the very left side, you have your reserve rack and the cooler. And on the very right side, you have the reserve rack and ambient. And then you have your cooler pick mod. And then you have your ambient pick mod. And then after it gets picked, it goes to 1 of 8 packing lanes. There's 4 fully automatic and 4 semi-automatic packing lanes. And then once it's packed, it goes to shipping. So some fun facts to hopefully give you a visual and idea of the scope is the throughput was 20 cartons a minute, and we had to design to the variability in their product sizes. So their smallest box was 6 inches by 9 inches and ½ pound, and their largest box was just under 20 by 18 at 70 pounds. For the zone routing pick mod, there were 20 pick zones total, 8 in the cooler and 12 in ambient. And we kept the zone per picker about 70 foot long to keep it ergonomic and efficient, so they didn't have to walk as long of distances. For the carton flow level, again, just pick mod stats, there were 387 carton flow levels. For the pick faces that Michael and the Alpine team slotted, there were over 1,200 in ambient carton flow. For pallet locations in ambient, there were 100. Cooler carton flow was 432, and then cooler pallet was 36. For racking, the total pallet positions was just over 12,500. For selective in the reserve rack, there was over 9,000. For pushback rack, that was above the pick mod carton flow levels, there was just under 3,000. And then for floor locations, for the pallets that they did case picks from, there's 344. Total feet of conveyor was just over 4,800. Over 3,000 of that was powered, and then there was about 1,700 that was gravity, because we had gravity flankers on each side of the pick mods. And then the WMS that we integrated with was SAP. So total, there were 32 scanners in this project and a camera tunnel for shipping. There were 3 main control panels that we put together to control everything in the system. There were 2 in ambient and 1 in the cooler. And then I mentioned it earlier, but for the pack stations, there were 4 fully automatic that went to 2 fully automatic case sealers and print and applies, and then 4 semi-automatic that they wanted for redundancy. I just touched on the pandas and the case sealers. And then shipping lanes, they had 4 shipping providers. So there were 5 shipping lanes, 1 for the hospital lane, and then 4 for the other carriers. So in this picture, in the top right picture, you can kind of see all that, the tall rack in the back, that's the ambient pick mod. And so it would come from the ambient and go to the left side of the picture, and that's packing. And then from packing, where I'm standing taking the picture, that's the print and apply and fully automatic case sealing lanes. So none of this would have been possible without our in-house software company and their COS software. It allowed us to make a warehouse control system that integrates the ambient pick mod, the cooler pick mod, the interface with their WMS system, control the sorters, the print and applies, all the equipment. It puts it into that warehouse control system to make it all work together and automate. And then ship manifest as well. And at the bottom are a couple of base packages of ours that we have depending on the functionality that the customer needs. COS is completely configurable and flexible to integrate with whether your WMS is a homegrown WMS or it's a standard offering on the market. As long as the data can talk, that's really all that matters. So it's a huge benefit of COS software. And now I will hand it over to Michael to get into the slotting specifics.
All right. So let's see what we got. Can you guys hear me back there, Eric? We all good? All right. How many people in here are currently slotting their facility once a month? Once a quarter? Once a year? Wow. Okay. So what's interesting is if you think about Zoetis, they have a peak season, right? So spring, all the flea, tick, all those types of things for their animals. Then they also have monthly subscriptions. So at the beginning of every month, they've got a peak. So you think about peak day, peak week, peak month, and they went and they built this amazing brand new facility. And everybody knows the best time to reslot is when you move into a brand new facility. You're touching the product anyway. Why not find it a new home and make it the right home? So we typically see, best in class, right? If you have in a CPG world where you have weekly promotions, you might be reslotting your Super A items and promotional items every week. And sometimes you do that tribal knowledge, sometimes Excel sheets, sometimes you use a third-party tool. So what we're going to talk about a little bit is kind of our approach. So Alpine is a boutique supply chain consulting company. 18 months ago, we probably had 15 brand new facilities that we were working on, doing the facility design, the layout, and then the slotting as part of the move plan moving in. And the last 18 months, this thing called COVID, most of our business has gone to manufacturers where they're trying to say, hey, I'm going to cannibalize 150,000 of my 300,000 square feet to add new manufacturing lines or new manufacturing capabilities. And as well, with the interest rates going up, a lot of people said, can I do more with less? So we've done more labor projects and more slotting projects to get some quick wins and some big bang buck. But let's talk about Zoetis. Zoetis making the right investment, being able to triple, quadruple their business within the same footprint. Okay, so when we think about slotting, you got to understand the rules to the game, because in warehousing, you have 4 assets: space, equipment, labor, and control. And the question is, what are you solving for? And then you can figure out how to address that with either additional labor or different types of equipment. So in our situation, they really wanted to make sure that they reduced the travel time, they wanted to reduce their picking costs, and they want to reduce replenishments and also do zone balancing. So think about that. So reduce the travel, great. So I got 80% of our items, 80% of our volume comes from 20% of our SKUs. So if I can figure out where best to put those 20% of my SKUs to minimize travel, good idea. The next one is reduce replenishment. So we talked about making sure that that forward pick location is properly sized. So I might only replenish it once every 2 weeks, or once every 3 weeks, or once every 4 weeks. But as you all know, in your business, I lost my microphone. There we go. In your business, maybe you actually have your A items, 20% of your SKUs. You might have super A's, medium A's, and low A's. And if you try and put, a week's worth of super A's in that forward pick location, it might be 3 pallet positions wide and 3 pallet positions deep, and it might not make sense for your business. So you got to really right-size those super A's to minimize that forward pick location. Now the last one here is zone balancing. And this is always tricky. So working with CSI, understanding that there's going to be 12 zones in this building, and they wanted to make sure that there's a levelness, that everybody has the same amount of work, and that all the zones are getting the same amount of work, so that way we can actually staff it appropriately. And when we look at all of these options, we can solve for them all, but there's going to be trade-offs. So we're going to talk a little bit about the trade-offs that we went through and the scenarios and the iterations that allowed us to make the right decision. So far, so good? Everybody understand the rules of the game? Metrics of success, project goals. Number 2, 2 types of racking, very simple, case flow and single deep pallet. Makes sense, everybody's got that. And then the layout have 4 zones in the cooler and then 12 zones in the ambient area, so 14 total zones across 2 multi-temperature environments. How many people in here have multi-temperature environments? 1, 2, 3. You guys have just 2 or 3? 4. Frozen. What's the hot room? Oh, geez. Cooler, cold, hot, and ambient. And then 4 Seasons Produce, you guys got the wet room, the chill room, the banana room, the avocado room, the ambient room. 7 zones. Somebody over here? How many zones? Just 2. All right. So now you guys know, though, all right, you might have a different rule within each of the different temperature controls, and then you think about the product characteristics. Heavy to light, stackability, packing into an outbound shipping box. We got to take all that in consideration. And the next one, believe it or not, when you move into a new facility, you got to have a location addressing system, right? So this is my aisle, odd on the left, even on the right, right? Odd, 1, 2, 3, 4. Then when you would get in with the aisle, level row position, making sure that your location addressing system works. Within SAP EWM, you want to direct a picker or replenisher or put away person specifically to that location so they can fulfill their demand. Okay, now, slotting assumptions. Only 791 SKUs. Not too bad. Jason and I had an opportunity 2 years ago to work with a customer that only had 150 SKUs, but they shipped 50,000 orders in a 10-hour period. We tried to figure out how to do it. We ended up with 10 mirrored pick lines to be able to get that volume out because they only had 150 SKUs. Here, we've got temperature controlled, 2 different rooms, and we have a different amount of SKUs. Then thinking about if in the event it is going to go to a pallet slot, I only want to give it 1 pallet facing versus 2 or 3. But in the case flow, right, now think about this. I'm going to get a little technical. A pallet position is about 60 to 70 cube. One single deep pallet location is 60 to 70 cube. But if I go into a case flow location, 15 cube, 30 cube, 45 cube, 60 cube, 70 cube. So if I go 6 slots, I might be able to put a full pallet within that, but I want to spread those 6 locations. I might have one over here, one over there to minimize congestion and spread it out. So now we're thinking a little bit about how we want to solve that. We have a weight issue. So on the lower level and the upper level, I never want anything more than 25 pounds in a case to go one of those levels. You don't want to have that bend and reach. You don't want to have anybody drop something or get hurt. Then we thought about the fact that we actually have length, width, height, or I might be able to do length versus width. The height was always going to be there. It's just the orientation of how you put that case within the case flow from the backside to pick from the front. Then we said if a SKU has a unit of measure of PL, which is pallet, then we always want it to be slotted in a pallet location. The last thing you want to do is receive a full pallet, take off 8 cases and bring that to the forward pick location and then put a almost full pallet away in a location and then replenish from that. Go put the full pallet away. Don't take the eat of 8 cases on receiving. So think about the receiving productivity, unit of measure, typical quantity, you bring it in and put it in the facility. All right, so now we're getting there. All right, so now there's this unbelievable vernacular. It's called a digital twin. Gartner came up with it. I love it. I used to call it, we're just going to build your building in either a slotting tool or an AutoCAD, but now it's called a digital twin. And we can do really cool things with your digital twin. So in this particular project, we used a product called OptiSlot. Optricity Corporation did the slotting for this project. So we used their tool, and we created a digital twin. So on the left-hand side, you can see that we've got the cooler pick, and then on the right-hand side, we've got the ambient pick. Now, this is a pick module with Conveyor, so we knew that we separated it out, and that way if there was a demand in that area, it would kick off and it would go into that area. So remember, one of their goals was to have everybody in all the zones have an even day's worth of work, okay? And then finalize the pick path. So not only you create the digital twin, but tell me what travel path you're gonna take and go through the building, XYZ travel coordinates, so we can do a simulation that says, here's a week's worth of orders, here's how much travel time, how much pick time, and then you can compare those options. All right, so very pretty color. These are the different zones, but again, it's just replicating the digital twin, and then time to pick. So now, this is a case flow location, and you can tell that when I actually go ahead and pick, I guess there's no laser pointer on here, but when I pick from level D, right, or level A, I have to bend down and pick, that's 4 seconds, versus I'm vertically challenged, it might even take me 6 seconds to pick from a higher level and bring it down. Versus in that golden zone, your time to pick is 3 and 3.5 seconds. So the ideal state would be to have all your A items in that golden zone, and then your B items probably in level B, and then D and A for your C items. All right, all seeing it visually, tracking? Good. All right, now average time to pick. So thinking about where we want to go and how we're going to travel. Again, the conveyor is going to take the tote or the carton to that picker, and then they're going to start at the one side, and they're going to pick, and as they're picking, going down, then they're done with their zone, they induct it back into the conveyor. So we had to set up the average pick cost within the digital twin, and then believe it or not, we came up with 5 scenarios, okay? Now in these 5 scenarios, we talked about the advantages and disadvantages, thinking about the original project goals. So in scenario 1, most of the high hitters are at the start of the pick module, which is good, but the disadvantage is that since we're prioritizing them, they're going to be scattered throughout the whole building. And while that gives everybody a full day's worth of work, what if we could skip zones and get it out of the building faster? If I could get all my picks done in 2 zones or 3 zones, what would that look like? Thinking about the cube movement. And then in scenario 2, while they're close to the stop node, all the pallet locations have higher hits compared to the case flow. So now I've got so many picks outside the pick module versus in the pick module, that's not the right balance either. So then in scenario 3, we kind of did a little high hitter scattered around, pallet locations, but now we're all in the golden zone. So now we've looked at all these scenarios. 4 and 5, same thing. So what happens is we go and we get smarter. What's the trade-off of these scenarios and really understanding it? So thinking about the ultimate goal is to smooth it out where everybody would get, and all the zones would get the right amount of picks. We looked at it and we said, you know what? That solution might not be the right answer. Maybe we could actually get more picks in less areas, and then we don't need a picker in some of those areas, or we could have one picker work multiple zones because we're not going to have a lot of picks in there. Okay, so we did 5 scenarios. Let's do some more. We've got the tools. Because the difference between scenario 1 and scenario 5, I mean, if you look at it, the total pick cost, $47,000, $52,000, $53,000, $52,000, $51,000, any of those scenarios are going to do okay. What's the congestion factor? How fast can I get them out? Like, okay, let's look at some different options. So now, looking at the hits within scenario 4 and 5, we decided, hey, let's look at some other things, right? Heavy to light. So believe it or not, when we took the very first tour, they had glass. So if this was their pick module, you're halfway through the pick module, and then all of a sudden you've got glass right here, and then you got bubble wrap on the other side, and you're bubble wrapping the glass. I'm like, we either do that at the very beginning of the pick, or you do that at the very end of the pick. But right here, this is a pick killer. So in pick to light, you're usually getting about 125 lines an hour, but all of a sudden, if you're bubble wrapping glass, your productivity goes way down. So okay, now we know that we've got the glass at the end, and it's going to take a extra process to bubble wrap, put it in the box. Ideally, you'd want it at the beginning, because that way it's on the bottom base, but actually if we bubble wrap it, we put it on the top, it's going to be protected. Okay, great, so at least we know that. Then the other one is heavy. So we know that there are certain products that are a little bit heavier, and so what we wanted to do is begin the heavy at the pick line. So when we induct it, we get a base within the box. Okay, so now we got 6 through 10. Now we look at these scenarios and we start to say, hey, am I getting a better balance across the pick modules? What's the time to pick? What's the value of picking this way? And then we actually came back and said, okay, great, scenario 6, how many replenishments are we gonna have? And how is that gonna drive our standard? So Jason and I had another customer, MJ Holding. They built this brand new facility, took 5 buildings into one, and the first thing he says to me is, Michael, I gotta fix my replenishment. Michael, I got a replenishment problem. I go, Mark, why do you have a replenishment problem? I got the data, I looked at it. Mark was moving 56 pallets of one item, picking at an each level in a week. And he was picking it out of case flow. You do not pick 56 pallets at an each level out of case flow. You get multiple pick faces of 3D pallet flow rack, and even then, his Super A items, he's replenishing twice a day. But I'm like, now Mark, I get it, right? And he had never had pallet flow in his building before, and we did, on the base level of his pick module, 3D pallet flow on both sides mirrored to hit his volumes on those high items. So here, we got some high moving items, and we know at the beginning of the month with those subscription versus the seasonal items have a different order profile. We want to make sure that we don't replenish too often. So in scenario 6, we have 188 replenishments a week. Let's talk about that. So in this goal, we said our A items, we're going to replenish once a week, our B items every 2 weeks, and our C items once a month. It's called time period and slot. And you could scale it down to 3 days for A items, 7 days for A items, 10 days for A items. So we were able to flex it a little bit and look at it and figure out what the right answer is. So scenario 6, 188, but our ones that need more than one replenishment a week is 16. That's not bad. right? 80% of your volume comes from 20% of your SKUs. If I have to replenish my Super A's more than once a week, that's not bad. Scenario 10, we're replenishing those Super A's 20 times a week, and while we have a little bit more replenishment, what we found on scenario 10 is that we actually had a better overall productivity. So scenario 10 shows us that we have 9 dedicated pickers and 1 floating picker. So now we have some orders that are gonna go get picked faster, get out of the building faster, and instead of having 12 pickers, now we only have 8 with 1 being able to float around. So then 9 and 1 floating around. So I've got 10 pickers versus 12, plus the 2 in the cooler, so that would have been 14, right? So it was an opportunity to just like take a look at it. So what does this mean? This means that if you properly size the 4-pick location and you think about how you want to manage your labor and minimize your travel and your replenishments, you might have to do some iterations and you might have to think about how you want to trade it off. We had another project just recently where their number 1 goal was to minimize picks and replenishments. I mean, increase pick productivity, but minimize replenishment. We were able to get them a 22% pick productivity and minimize replenishments by 16%. That literally moved the needle. This was a publicly traded retail company, and they got the benefit before they went back to school. And the SVP of operations right now is a hero with that huge win. Not only that, but we actually slotted the DCs for store put away. So they did it by brand, and then they did it by male and female within the brand. So these pallets were getting to the back of the stores, ready to be put away quicker and faster. So the operations team at the retail site actually got the benefit, as well as the distribution center. It was a huge win for the company. Okay, so let's think about it. Results and next steps. So once you go through, you set your goals, rules, and constraints, you know where all the new items are going, you can create a move plan. So they're in their existing building, aisle, level, bay, row position. And what's your name?
Drew.
Drew. So Drew, we know, is an A item, and he's gonna go in the new building in aisle 2. So we actually go, sticker Drew, and then when they do the move plan, they get in the new building, aisle 1, aisle 2, and they put Drew away. So we help them from their old building to the new building, knowing where the items were gonna eventually be slotted, and then we could actually placard and put things in there to move over there. Now, that was one part of it. The other part of it is, now they're in the environment and they start picking. And do we have the realistic numbers that they're achieving? Do we have an update on it? Right. So I think we built the business case on maybe 120 lines per hour. And what are they hitting right now? Like 150, 155? Yeah. So, you know, I would rather under-promise and over-deliver than over-promise and under-deliver. So we built the business case on 120 lines and are hitting about 155, 160 right now. Replenishments are way down, and the product damage is also way down. Remember, we talked about all that glass. So that was a huge benefit for this organization. So a couple of key things. Pareto's Law, 80% of your volume comes from 20% of your SKUs. If you can properly slot those 20%, you're winning. If you can properly slot the A's and the B's, you're really cooking with gas. And when you move into a brand new facility is the ideal time to reslot your facility. So with that being said, I think we're gonna open it up for some questions. Any questions? I guess the big lesson learned is allocation of zones. You don't need a picker per zone. Even though they designed the facility for that, we found that you could actually hit the volumes and not need that. And then no one has clean data. So when you go to slot, you need the item master file. Not everybody has the item dimension of the each, the inner pack, the case, how many cases per pallet. It's okay. We'll solve for the A's and then apply a proxy dimension strategy. Resource turnover. I mean, that was, I think because they were moving out of one building into another, they lost some resources, and so they had to hire some new people in the new building and teach them about the products. But yeah, very cool. Any questions? So the question is, did you use any dynamic picking or dynamic slotting in your modules? For Zoetis, we did not, but we have a lot of apparel, footwear, and promotional companies that absolutely do, knowing that, I can say this because they spoke at WERC, Comar is the #1 pajama company in the world. So if you buy your pajamas at Target or Nordstrom, they probably come from Comar. Their average life cycle is 45 days of an item. So it comes in and it goes out within 45 days. So to set up a forward pick location and have it always get replenished in a dynamic environment like that, you're better off with dynamic slotting, using a sales forecast and making changes after 5 or 7 days. It said it was going to be A item, it's moving like a B, get it to a B location, here's a C item, we didn't think it was going to move, but it's moving in A volume, get it into an A slot. So no, in Zoetis we didn't, but yes, we do dynamic slotting. Right, you got to think about it, it's animal health, right? It's pretty static, there isn't a lot of turnover. Right. Any other questions? Yes. Great question. Did you do anything about the inbound portion of the business? Because they went from 67,000 square feet to 218,000 square feet, right? So I think Carly showed you they had a reserve location and they had pick modules. So now we were able to bring the stuff that comes in less than pallet quantity into a hand stack or right into the case flow pick area, and then the reserve storage was there and bring it into the forward pick location. We did not do anything on the inbound here, but let me tell you about Advanced Auto Parts. So Joe O'Connor had a facility, Advanced Auto Parts, that was probably twice the amount of labor as the rest of his facility. And Joe and I said, we have 109,000 SKUs, of which 7,000 move a week and 15,000 move a month. Why do I put everything away by manufacturer? It makes absolutely no sense. Let's go and set up a fast picking area, and let's do the math that says, hey, I get an international container from XYZ manufacturer, and I go put it away in one aisle. Well, now I'm going to check it in, and I'm going to put my A's in a pick module over here, my B's and C's go over there. They had a 3% put away productivity decrease, but they gained 12.5% on the pick productivity. So his net was about 8.5 points. Joe said, I'll take 8.5 points all day long. So for them, we did do the put away analysis that says now I'm putting an item, a manufacturer away in 2 locations versus 1. So did that answer your question? Yeah, absolutely. Great question. Any other questions out here? Yes, sir. So it's SAP EWM integrated into Conveyor Solutions COS, WCS, and WES, doing the cartonization, picking directly into the outbound box, and then going through an inline scale to validate that the weight tolerance is there, top tape, void fill, print and apply, and out the door. Did that answer your question? Great. Any other questions? I can see you back there. Can somebody relay that? What was the ROI? So I think the overall business case was less than 24 months for the brand new facility, the pick to light, and the conveyor. And that was at 120 lines an hour. So at 150, they're probably about 18 months return on investment. Jason and I had another client, they spent $9.6 million. The business case was at 20 months, and they actually achieved it in 11. Because they were doing 290 lines per hour, picking on a pick to light. Very cool. Any other questions? You want to, oh, you got it up all right? Well, on the behalf of Alpine and Conveyor Solutions, thank you guys so much for taking the time and investing in slotting. Have a great slotting day.